I got me one of the super cheap combination import vices here. It's the kind that has normal vice on one side and some kind of a pipe jaw clamping arrangement on the other side. So you can kind of clamp some round stock in here and do, I think they are intended for example, for threading pipe, but I wouldn't trust to do threading on a 1-inch steel pipe, for example, with this vise. I didn't have much expectation when I ordered it, but I have to be honest, for 75 euros, it's an okay vise. The paint job is atrocious, but the jaw wobble is acceptable. The jaws themselves seem to be hardened. I will put them under the hardness tester later. They have an atrocious rough waffle pattern in here. I will surface grind these. And the other side with the pipe jaws, the horizontal pipe jaws here are only cast and not machined. And then they have these inset jaws to hold, for example, disc-shaped objects, something like this. I can see this working, but I bought this for a very specific reason. I have a very, very good Hoyer front forged steel vise. This is an extremely good bench vise, large range of clamping range, replaceable jaws, hardened, and very massive trapezoidal screw. These are kind of the standard vise in most machine shops and fab shops here in Germany. You can pick these up used for relatively small money or buy them still new. Really good vise. And I have set it up in a way it's bolted down with 4 M8 screws. So when I need the entire surface of the bench, for example, when I want to use my sheet metal shear, this comes unscrewed. And it comes off the bench very quickly. And I went so far to have 2 screws sticking out there out of the side of my bench to give it a space to live when it's not in use. And it goes back on very quickly. But the problem is, first of all, as you have seen, it's not always mounted to the bench. And secondly, I would like to have a vise next to the CNC mill, but also I need a tightening fixture for the HSK tool holders of the CNC mill. These are available commercially, but I don't want to spend bench space for the mounting fixture. So my idea was to use the cheap vise as bench vise on the CNC for quick deburr or stock preparation, for example, and machine a set of soft jaws to allow me to hold the HSK tool holders from the CNC in here to do my tool tightening and color changing and whatever I have to do to these. This OD here is always the same diameter on these HSK tool holders. No matter if it's an HSK type A like this one or an HSK type C for manual operation like this one. The A one goes in usually in machines with a tool changer, and the C is exclusively for machines that don't have a tool changer, like rotary transfer machines or linear transfer machines, where you just have a spindle unit that always does the same task. That's what these Type C holders are mostly used for. But they both fit into a manual tool changing spindle. It's just these have a little bit simpler geometry on this recess here, but the diameter is the same. So I can grab on this diameter to tighten these. These have a wrench flat, but I find it kind of clumsy to do it like this. I'm not the biggest fan. Having them clamped down to be able to tighten and loosen the jaw up here will be very nice. And when I don't need the tightening fixture, I have a benchvise on the other side. We'll do surface grind the jaws so I don't put a nice waffle pattern into the parts I'm working on. But from that will be nice. So we need to get these jaws out. These are screwed in with some really messed up Phillips head screws. So let's see. Okay. These are the V jaws. These go. I don't want to keep these. Going to make some aluminium inserts and machine some clearance in here for the HSK, for the tool holders. On this side we have the waffle pattern jaws. These also need to come out. And this will also be semi-permanently bolted to the bench. I'll put in some threaded insert into the bench on this side. So if I need the entire bench surface, I can just pull out 4 bolts and remove the vise from the bench. So it's all painted below the jaws on both sides, so we might run an end mill through there just to clean it up. Doesn't hurt. Also, the base on the underside is very uneven and painted, so going to chuck that in the lathe and just give it a quick facing cut. The anvil surface back here needs some deburring. Won't use it as an anvil much because this is just cast iron. And in no way this is a match for the Hoya front bench vise in the other room. This is all cast iron, and I suspect the nut back here being the weak spot. But I don't want to use this to gronk down on parts. I just want to hold stuff for a little bit of deburring or whatever, just a helping hand. I'm also not the kind of person that beats on stuff that's held in a bench vise with a hammer. I don't see the point in it. That usually just ruins the vise, and you're usually at a point where stuff is going really wrong if you need to do that. And usually there is a better way of doing stuff than beating on it with a hammer. Well, beating on stuff with a hammer is often a very good solution, but beating on stuff held in a vise is not very elegant. So I try to not do it. So these are the jaws. Let's give the jaws a quick hardness test. Well, one of the jaws at least. Testing Rockwell hardness C here, of course. Preloading. Indenting. Now all the measuring force is applied. And the next step will the indicator up here will show the actual hardness of our jaw. This is not terrible. This reads between 54 and 55 Rockwell C. In my book, that's considered hardened. Okay, let's get this thing apart before we do any work to it. Let's see, lock nut. Well, it has at least a trapezoidal screw in there. And this is probably the most concerning part because all of this seems to be a casting. If something is going to fail, it's either this cast iron pipe here, that also has a slot for the nut in it. Yeah, the nut definitely is a weak spot. When you look at this part, this is a very, very entertaining shaped part. This is made in a way so the nut can ride inside this pipe. Well, I guess for just holding stuff without reefing on it, this is fine. I'm not overly concerned. And if something breaks, I can always braze it or make it in steel new. So, okay. That's the fixed jaw body. Also, when did we start to call this a dynamic jaw? There is nothing dynamic about a vice jaw. It's a moving jaw or a fixed jaw. I'm going to replace all of these handles with a little bit nicer clamping handles. Oh, these are annoying to remove. Also, these will get replaced because I don't like them very much. That's the vice body. Also, just a relatively thin-walled casting, so don't expect any crazy strength from this. This is the base casting, and this is the retainer ring that goes in here and locks this casting on top. I think I will put this on the lathe and face both sides just to make it sit a little bit nicer on the table. So I took a first pass on the base plate of the vise to clean up the 4 feet. And the casting has only 4 feet. The section between is relieved. I took a 0.5 millimeter cut and 2 of the feet cleaned up. One cleaned partially and this one, well, it's barely touching. So I'm going to take another 0.5 millimeters and then it should be all flat. I'm not striving for high precision on this quick project. Just want to make it a little bit nicer than it out of the box. I'm running 200 RPM and a feed of 0.1 millimeter per rev, feeding in radially. Of course, we have a heavy interrupted cut here. The carbide insert I'm running is not for cast iron. This is a relatively sharp insert for stainless. But since it's already a used cutting edge, I'm going with it. So if I bust it, I'm not too sad. But it seems to handle the interrupted cut quite nicely. This cut cleaned up all 4 of the feet and the carbide insert is still there. It's not, the cast iron on this casting machines quite nicely. Doesn't seem to behave any weird. Sometimes you get cast iron that is very, very dusty to machine. This tends to make a chip at least. So at least it doesn't rattle on the table anymore. And for clamping, I just held it in the 6th jaw from the inside. I'm trying not to make a science fair project out of this one. Next, I would like to clean up this surface here. This is where the main body of the vise clamps up against too. So let's see if we can get the same arrangement. But this looks doable. So now our machine surfaces, the pads rest against the jaws. Doesn't line up extremely well since it's a 6 jaw and we have 4 pads, but it kind of averages out. The pads all rest on one of the jaws, so it should come out flattish or parallel-ish. Yeah, I'm also not concerned with run out, of course. I'm only looking for parallelism. Yeah, I'm not chamfering this in the machine since it's running rather not true. So that's looking good. Cleaned up the entire face except for one little casting blemish here, but it's fine. I just did 3 peel grinding passes, means relatively high depth of cut and extremely small step over, so most of the edge of the wheel is working compared to the entire face. That's a very good technique on low powered grinder like this one. And I took off 0.6 millimeters in total just to get rid of the extreme rough waffle patterning in there. Now there are smooth hard jaws. We have to rebore the counterbores because those are countersinks that are tapered and not deep enough anymore. I don't want to use countersunk screws here, I want counterbored. So first side, let's make them parallel on the back side because they are very rough on the back side. And since I'm machining the seats that these are resting and getting bolted into, I want them to be clean and flat so they don't mar up the surface. So I'm not really looking for high precision here on these jaws. It's just a benchvise. We're already overdoing it by a lot. Okay, 2 sides parallel. Now we put them in a grinding vise, both up against each other. Grind the third side, put them the other way around on a magnet, and square and parallel grind the back side. And this allows us to grind these sides, these 2 sides, square to the sides that we just made parallel to each other. Otherwise we would have to use something like either step grinding or a squaring chuck, which step grinding on such a small part is annoying, and I don't have a squaring chuck. And these are not very matched, to be honest. So let's clean those up. Okay, squared those two sides to the major faces. Now I can flip it on its back. Without the magnet. This is a very rough way of squaring. If I was really out for precision, I would have taken So here are the two jaws all cleaned up. Only needs to be deburred, and we need to rebore the countersinks into counterbores. I decided to clean up the ends too, since while I'm here at the grinder, it's not really much more effort. One last step is to use the V-block, magnetic V-block. And jaws have a relief chamfer in here that's very inconsistent. Both of the jaws, I'm going to match grind them. Means both the same sized chamfer. Apart from facing the underside and the top side of the foot, I didn't do any machining to it yet. I only scraped off all the paint from the machine surfaces, and everything is okay machined. This ring got some deburring, just with a handheld die grinder. So let's put it together. I don't want to make a huge project out of this. So don't expect any magic. If I was in a better mood, I would spot face these holes, but this will do fine. Until I want to change that, I'm going with a washer instead. Also, I'm not using these these original handles to clamp the rotation of the vise, because I don't plan to do a lot of rotation here. In reality, I could ditch the foot entirely and bolt this casting directly to the table too, but I feel like the base gives it a little bit more stability. And maybe I need to swivel it one day. Clean this one. Well, stop. This one goes back in here. Well, on this side. And in theory we have, there used to be a clamping screw, which for now we will put in here. We'll make something a little bit nicer. Then we have the moving jaw, which is not a dynamic jaw. Okay, these counter bores are too small in diameter and also tapered on the bottom, so these need to be remachined. This is the traveling nut that goes in here. I don't want to use the original screws. These are really not very nice hardware. I would prefer to use black screws, but I only have zinc plated in this size. But these are also strength 8.8. Probably still better than what used to be in there. This is going to be a masterful setup. I have two 1-2-3 blocks, and this casting has a machined surface all around, which can rest on the blocks. Then I bring in this clamp, and I'm clamping over the 1-2-3 block. I'm not clamping in the center because I'm worried that I might just break the center part by pushing onto it with the clamp. Well, it's probably fine since the vise also clamps, puts all the loads through the nut, but better be safe than sorry. I'm using a drill bit to align everything, and then I change to a counter bore. Can't use the counter bore for alignment because the pilot is too short. Okay, sometimes when you work with castings you end up with a situation where there is just not enough material, and to be honest, this looks like ass. And suddenly it became a project. I'm doing what I always do when I have a counter bore that breaks through the side of a part. I'm using an end mill and I'm making more a cutout so I don't have this whisper thin piece of material. Well. How did I set it up? I eyeballed the two bores to be in line with the y-axis of the mill. Then I used a 6mm shank of an end mill in a collet. Then I just picked up my hole coordinates, and I didn't do much real alignment here. So just pick up the bores and then milled from the center point of the bores out towards the center. And eyeballing it straight here is good enough for this purpose, since on this casting there are about half a straight surface. Okay, rear plate is on. This doesn't really have to be super tight. As you can see, it's still wiggling. I didn't tighten it fully down. The lead screw of the vise will actually pull it tight against this middle part and cinch down for this rotation, so this locking screw here is only so it doesn't move on its own, and also will of course clamp the work here. So let's put the screw in. Let's see how tight we can go before it all jams up. I think I have used vices that have more slop in it. This doesn't make this a high-end bench vise, of course, but also it's less than 80 euros. So who am I to complain here? Okay, next we'll machine the seats for the hard jaws. Okay, let's get it somewhat level. Yeah, this is the cheapest of cheap construction levels that you can get. But for rough alignment, it's okay. Good construction levels are really relatively precise. This one is not. So we start at 0. We have a tendency of 0.2 millimeters rising. So let's see if we can. Give a little bit of alignment here. 0 here. Yeah, it wobbles around 0 plus minus like 0.1 millimeter. That's fine. I'm not going to mess any further with it. I'm clamping a parallel down here, so everything that's loose is tight. Hopefully I don't crack anything. Let's see, 0. Yeah, this is fine. Okay, and now let's align the jaw with the travel. Like this. This is the swivel base adjustment. I'm just aligning it so I don't remove a whole lot of material unnecessarily. Let's see. Yeah. Okay, that's fine. Let's tighten it down on the swivel base. And let's see if this thing is rigid enough so we can run an end mill through there without any additional measure, without any additional work holding in front here. Otherwise we will have to put maybe 2 screw jacks under here and a strap clamp on top here. But let's try it with this 10mm carbide end mill and taking relatively light cuts. Maybe it doesn't explode in my face. Okay, first pass I was only scratching off paint, and also I might have hand cranked a little bit too harsh in C. Let's give it 0.2 millimeters depth of cut sideways. Well, not good, not terrible. Let's step it down to additional 0.1 millimeters and let's try a higher RPM. Okay, that already cleaned up the fixed jaw. I'm dropping down to clean up the floor of this step. The darn thing moved on me, which was kind of to expected. And this happens when you want to take shortcuts. So let's check our indicator. Or didn't it move? It looked like it moved. Huh. Okay, it didn't move. On this surface. Okay, I was only paranoid. But I think we're going to do something against the possibility of anything squirming around. I'm losing my confidence right here. Let me cobble something together. I'm very proud of this setup. I have a screw jack down here supporting the moving jaw, and I have a strap clamp clamping in here on top of the moving jaw. So this should give a little bit of additional stiffness in the setup. Round 2 of hopefully not exploding in my face. Okay, that went way better than before. Now I'm recutting the fixed jaw too, because I think the clamp kind of moved stuff a little bit around. Also, this one has to be lower. Well, this one came out a little bit lower to be cleaned up, so I have to recut the height on the other one too. I've taken the hard jaws and bolted them in. It really looks okay, as far as I can tell when I tighten it down. Unfortunately, it will be easier to play with it once it's off the mill table. But I have to say, it closes up okay. There is, of course, a mismatch. Also, I haven't aligned anything yet. But now I can cut the other side. And for that I want to preload the jaws a little bit, just by adding a spacer in here, parallel. So it's all clamped together. Can't tighten it fully because when I still need to be able to swing it to the other side. Now I can align it over here like this. Then tighten down here, support it on both sides with a screw jack, add some strap clamps, and cut clearance up here for the HSK tool holder so we can use a tightening fixture in there. Okay, let's get it level first. My precision bubble level. Ugh. I'm really not after any real precision here. I just don't want it to look all crooked. So start at 30 and we come to, we raise to 40. So let's give it a little bit of an alignment here. Okay, that's fine. Cinch down this bolt, cinch down the lock here, the clamp handle. Okay. Yeah, we're averaging at 35 here. Okay, cleaning up the surface for the soft jaws went very uneventful. I had a strap clamp down here and a screw jack below it. The clamp without the screw jack would be absolutely useless and counterproductive because I would just bend the entire casting down. Every time you clamp something down with a strap clamp, you want support underneath the strap clamp. Otherwise, it's just adding stress and strain to your setup. I have some pointy set screws in the 3 mounting threads, and I'm transfer punching onto the soft jaws. I machined the soft jaws off camera. These are just a piece of cast aluminum plate, 5083 aluminium, milled, then clamped together with a spacer in between, and I bored a hole into it that matches the diameter of the HSK32 tool holder. Guess what? On a HSK32, this diameter is 32 millimeters. On a HSK40, this diameter is 40. I'm transfer punching them because the hole locations are not very precise, even numbers. So I figure transfer punching will be less painful. Yeah, and I got nice punch marks. Problem is this one. I was worried that this might be a problem. This one is too close to my jaw geometry. Okay, I will I will have to drill 2 new holes over here because this one is too close to the center of to the wall of the soft jaw. I can't get the counter bore for the head in there. Okay, I transfer drilled the second soft jaw into the vise body, and well, let's put it on the drill press. Stuff like this is why I got the large drill press. Despite it being quite the and while we're here, we can also tap them. I know, this project is not my usual kind of attention to detail. This is more I need something and I need it in a reasonable time frame, and I don't want to make it a science project, at least this time. Hello? Longtime viewers might remember this thing. This is my chamfer milling machine, or deburr machine. I have a video on the specs of it. It's a router motor with an end mill with a V-block above it. So very simple construction, but highly effective. My idea was to put the steel plate under the wooden top and put the vise on top of it and screw through the bench with M8 screws. So the wood is sandwiched between the steel plate and the bench. This would make for a very solid connection. But it would crush the wood over time, so I'm not 100% sure anymore if this is the right move. On the other hand, if I do this, with the steel plate down here, with the threads in it, it's very easy to remove the vise. It's just 4 machine screws to be removed. But I'm worried that I'm not able to tighten down the screws strong enough on the wood, because the wood will crush under the pressure, to hold the vise firmly in place. So now I'm in a little bit of a pickle situation here. If I put the steel plate on top of the bench, and I remove the vise, I have always the steel plate in the way. But what I can do is I'm going to put the steel plate on the underside, put the vise on top, and if I notice that the wood will not hold up, I can still add a second, maybe even a thinner plate with a smaller footprint to the top, like a big washer that can be removed with the vise if I need to. So this will go on the underside. I will put in 4 wood screws so the steel plate doesn't fall off. So laying out those holes, going in 25 millimeters from each edge, scribing a line. Many people don't notice, it seems, on our standard caliper, no matter if it's vernier, dial or digital. You have OD, ID measurement, depth measurement, and a second depth measurement. This step back here is also a measurement surface. When the caliper is completely closed, this is flush up here, and when you set it to, for example, 25 millimeters, you get a 25 millimeter step here. This is often easier to measure distances from an edge to a part that's proud of it. Like if I want to measure against this hammer with depth measurement, this is very wiggly and very uncertain. If I go here and I have all of this flat surface that can engage with my reference surface, and then I can just push this up against my measured item. So super useful. Also, if you're careful, you can also use this to lay out lines. It's like a marking gauge for a woodworker that way. You run a scribe across the upper edge here. The upper surface here. This is not good for the caliper, of course. You will damage it over time, but this is a vernier caliper. It's good for 50 microns. So it's better than doing this with calipers, which I will also do, but this is better. So I have some reasonable nice screws here. The steel plate and the bench top together are a little bit less than 40 millimeters. Would be nice if I had 35 millimeter screws. There we go. Let's take these. 4 of these. They need a 8 millimeter countersink and a through hole with 4.5 millimeters. Time to match drill it to the bench. So I aligned it with the edge of the work plate or tabletop, clamping it in place. And I'm just using the tap drill of the M8 holes to match drill the plate. Now we open them up to be a clearance on the M8 screws. A good trick for opening up holes is a countersink. This works also in aluminum and steel, by the way. I have drilled fairly large holes in machine structures where I couldn't reach in with a mag drill, or nothing on the machine was magnetic at all. Just with exactly one of these cordless drills and increasingly larger countersinks. Works better in my experience than a step drill or the conical type of sheet metal drill. And I'm drilling from two sides to prevent a little bit of blowout. So bolting it down. Yeah, that's a funny extension. Okay, that's all deburred with a file and balled over on the edges. Now I take some emery cloth, 180 grit. and run it over the chamfers and the cornice. So let's clean up all surfaces on some 320 emery paper. Well, this is silicon carbide paper. I anodized the aluminum soft jaws. I did this at home. I have an anodizing setup in the basement, which is not ideal. I will show it at some point, but it's really just a few chemicals in plastic bins and a power supply and a hot plate. And also there are better places to look for resources for anodizing than me. My anodizing setup is basically only for home shop stuff, not for customer parts, because I have a very, very good commercial anodizer. So let's mount these. Using a tool holder held between the jaws to align them while I tighten it down. Time will show if the aluminum jaws hold up or if I need to remake them out of steel. Okay, there we go. Now I can work and manipulate on these HSK tool holders for the CNC mill without any trouble. Clamp, take them out. Only clamping on the major diameter here, not touching the taper, which is nice. And if I need, I have a bench vise over here that's not, well, it's not a vise for fabrication work. You don't bend a 100 by 10 millimeter copper bar in it to run high current power somewhere, but it's a nice assembly and deburr wise. The surface ground jaws are smooth and don't mar the work. It holds Arova pallets for mounting the pull stud. It allows me to deburr part of the CNC and things like that. Just a helping hand when you need it. It's a little bit crusty in some places, but this cost less than 100 euros. It's a lot of iron that I got, and even out of the box it was okay if you have use for the pipe jaw arrangement over here, which I didn't have. So, hope you enjoyed. Thank you all for watching, and I'll be back.